Uh, Good evening, everyone. My name is Sridhar, and I am from CSCF section. And for the complex engineering problem, data structures, my topic is about efficient array-based queue management for IoT sensor data processing. Here, we can see the IoT device or data processing, which are like IoT introduction to IoT sensor data processing. IoT devices generate vast amount of sensors uh, vast amount of sensor data that require efficient management, and also a proper queue management is essential to handle the data streams effectively. And this presentation explores array-based queue techniques optimized for IoT environments. Here, the introduction for the IoT sensor data processing. IoT devices generate a vast amount of sensors, which are like a very huge amount of sensors, which require efficient management. And the proper queue management is essential to handle data streams effectively. This presentation will explain you about the IoT environments and the optimization technique. Importance of queue management in IoT. Queue facilitate orderly data processing and prevent data loss. Efficient queues reduce latency and improves overall system performance. Proper management ensures scalability as the number of sensor increases. Here, there are like most importance of the queue management in IoT devices, which are like Internet of Things devices, which are like queue facilitates the orderly processing and also prevent the data loss, and which is efficient in using the reducing the latency and also improving the overall system performance, which also properly management ensures the scalability and the number of sensor increases. And now we see about the traditional queue structures. Here, the traditional common queues include linked list circular buffers and also array-based queues. Here, arrays provides fast access but can have limitation in dynamic resizing. And choosing the right structure depends on application specified requirements. Here some of the traditional queue structures, which are like the common queues, and which are like includes we have mostly uses a linked list and also circular buffers and array based queues. And as this array provides the fast access but can have the limitation in dynamic resizing, which also we are like choosing the right structure depends upon the application specific requirements. And then let us discuss about the array based queue overview. Array based queues store data sequentially in contiguous memory locations. They offer constant time access to implement and simple implementation, and also these they offer a constant access time to elements. However, they suffer from issues like data shifting during DQ operations. Here, like some of the overview of the array-based queue, and also then let's discuss about the challenges with array-based queues in IoT. Here, the DQ operation may require shifting elements, leading to inefficiencies. Here, while DQ, they are which leads to having the shifting operation, which also leading to the inefficiency. And also static array sizes can limit scalability in dynamic sensor network, and also managing the overflow and underflow condition is critical for reliable data processing. And then now let us discuss about the circular buffer implementation. Circular buffer reuse the array space by wrapping around at the ends. The circular buffers are also known as wrapping with both the ends, which are like using for DQs, such as they eliminate the need for shifting elements during DQ operation. And also this approach enhances the efficiency and supports continuous data strips. In circular buffer implementation, we have high efficiency and also continuous data streams. This also eliminates the need for shifting the elements during the DQ operations. Advantages of a array, circular arrays in IoT. Here, improved performance due to constant time NQ and DQ. Here, better memory utilization through wrapping around. This is the most important advantages of a circular array in IoT, which are like suitable for real-time processing where speed is crucial. Here we're having when we are like using the circular arrays in IoT, there is a huge advantage of having a improved performance, where also the constant time during the NQ and DQ. which is also useful for memory utilization and wrapping around. And this is the most important for and also crucial for the speed for real-time processing. Then let us discuss about the dynamic array strategies. Dynamic array resize automatically to accommodate increasing data. And also resizing can be costly, so strategies like doubling size are used to minimize overhead. And also the combining the dynamic array with circular logic can optimize performance further. Here, like the some of the things for the strategies for dynamic array, like resizing automatically, which also accommodate more number of data, and also which is increasing data. Which resizing can be costly, and so strategies like doubling size are mostly useful for minimizing the overhead and doubling size, which also combining the dynamic array with the circular logic, which optimize the performance very well for the further usage. Now let us discuss about the managing overflow and underflow. Here, it's most important to manage the underflow and overflow in the queue implementation, also in even in the stack implementation. Implementing size checks prevent data loss during overflow, and also underflow conditions are managed by ensuring the queue is not empty before the dequeue. Proper error handling is essential for robust IoT data processing. Here we are likely to discuss about the things such as the overflow occurs only when the queue is full, and there is no invitation for the data to enter into this. But and also the underflow occurs only when the I mean the uh, like what the queue is empty, and like we are like dequeuing from the queue where it is empty, then the underflow occurs, and the overflow occurs when having the enqueuing the queue, where we are like adding some of the data to the queue, which may occurs and also causes overflow and underflow under the circumstances. And then now the performance optimization techniques. Using lock-free algorithm can enhance concurrency in multi-thread environments. Pre-allocating memory reduces dynamic resizing overhead. Prioritizing data based on sensor importance can improve processing efficiency. Now let us discuss about the performance optimization techniques such as like log-free algorithms can also enhances the concurrency in multi-threaded environments. In pre-allocating dynamic resizing overhead reduces by the pre-allocating memory, and also prioritizing data based on a sensor importance can improve processing efficiency. And now let us see about a case study, which is like smart agriculture sensors. Here we are seeing we are having the IoT devices which are like smart agriculture sensors. Efficient array-based queue enable real-time soil moisture monitoring. Here we are like monitoring the soil moisture, where they allow seamless data collection from multiple sensors simultaneously. Here the sensor is getting the information from multiple sensors simultaneously, and also improved data handling supports timely irrigation decision. Here uh, here the basically the case study is all about the smart agriculture sensor, where the sensor detects the moisture content in the soil, then so that the water has to be needed to the soil. If the moisture content in the soil is low, it triggers to the queue, and then uh, the water has been kept to the soil. Here, the efficiency array based to enable the real-time soil monitoring system, which allows the seamless data collection, like having a huge data collection from multiple sensors like simultaneously at a time. This improved data handling supports the timely irrigation decisions. And then implementations consideration. Selecting appropriate size based on sensor data rate, ensuring thread safety in concurrent data access, and also access scenarios, and also monitoring queue performance metrics for ongoing optimization. Here, like some of the things such as like selecting the appropriate size on the sensor data rate, and also ensuring the thread safety is in concurrent data access scenarios is the most important thing during the implementation. Future trends in IoT data queue management, integration of machine learning for predictive Queue management, use of adaptive algorithm to dynamically optimize queue performance. Development of hybrid queue structures combining multiple data management techniques. Here are some of the future trends which are like integrating the machine learning for predictive queue management and also having some of the things like using the adaptive algorithms for dynamically optimizing the queue performance and also developing the hybrid queue structures. Then the conclusion is all about array-based queues are vital for efficient IoT sensor data processing. Circular buffers and dynamic arrays address many challenges faced in deployment. Ongoing innovation will further enhance data management compatibilities. Then there are like some of the differences like one IEEE transaction on industrial informatics and also efficient data structure from for IoT sensor networks. And this is all about the usage in the IoT sensors. Thank you.